Okay, so today we'll continue our DevOps journey, our DevOps learning journey, right? Uh, okay, so yesterday one of the major things. Let me just give a very quick recap of what we were able to discuss yesterday. Alright, I'll try as much as possible to make it brief so that we just dive into today's class. Right? Um, and as we always do, right, we will try as much as possible to share this link across to um, our platform, our different platforms, to be sure that okay, the one that we are carrying everybody along, and second of all um, that we are actually um, reaching out to more people. And so, if you find yourself or you find yourself watching this this class later, or you find yourself watching this while you are still live, try as much as possible to share this across to as much people as you can, right? So this is we are still watching this from pre-code camp. Like I said, our goal for this is just to um, accountability. That's our primary goal, just for accountability, for me to be able to be accountable, right? Because I want to be doing this every day. I have a lot of engagement. That's why I started this live learning section. And secondly, I now notice that okay, this can actually extend to other people, right? Like you that will see this video later, or that is still seeing this video now, right? It can be extended to you where you know you can come and we interact. Right. Currently, it's only one person that is just watching this video now. Right. You can interact and um, um, understand, together. You can ask your question. The way the whole class is actually is that um, as the instructor is instructing or is teaching, I pause the video at intervals. I try to explain some deep concepts, giving my prior understanding about back-end system and back-end engineering. So I think I have some stuff, some knowledge that I can use to relate with what he's saying, right? And I can really have some things to explain a little bit better. And so if you're new to DevOps from or you're coming from another platform, another sector that is on an IT world, right? Or you're already an IT guy and you want to really understand DevOps, I think this is a good place. This channel is a good place for you, right? Because as much as the instructor is instructing, right, you try to just explain what is happening, right? You try to dive deep into what is being talked about. Like yesterday, we try as much as possible to explain these concepts. Um, we explain this here using a diagram, right? And so we try to break things down here, right, a little bit further. And so if you have any question, you drop in a comment section. We actually have to we will tackle it as fast as we can, right? So if you're a senior dev, you are still welcome here, right, to actually judge and query my output, right, so that you can learn together. In fact, what I'm doing, I'm still learning. Right, that's the purpose of this. Right, so that's just the agenda here. That's the agenda here. Okay. Um, so I want to reiterate. or about what we talked about yesterday, right? The major thing we talked about yesterday. And so yesterday we focused on talking about the Docker architecture, right? How the architecture of Docker works, how the architecture is, how the architecture was designed, how the flow really works, right? That's what we focused on. We started. So I have my notes here, right? I have my notes here. So which I would still encourage you to have your own notes, right? And also this live section will also teach you. We started. So I have my notes here. Okay, so this live this live session will teach you on how to, you know, watch tutorials, right? On how to watch tutorials, on how to be able to engage videos and get the best out of it, right? Excuse me. Right. So yeah, moving forward to our class yesterday, right? One of the things that actually stood out yesterday was the architectural design of Docker, right? As much as possible, as much as we talked about the difference between a server and a container, right? And we defined a container and what a container is, right? We majorly focus on the architectural design of Docker, right? So I would just want to give you a rundown of what we talked about. So we defined a container as a lightweight, isolated process, running inside a shared host, right? Shared host in our case now is an operating system, right, which we talked about yesterday, right? And it packages it has a full package of everything that it needs, right, for it to run an application, for it to start a container, right, which includes a library, the code, the environment variable, the runtime, and the dependencies and the config files, right. A that's what so that's what a container is, right? So before we try to define a container, we looked at what a process is, right? And a process actually ushered us into defining what a container is. And so we said that a process is simply is a running instance of a program, right? Is a running instance of a program that has its own CPU context, its own memory and system resources, right? That is being managed by the kernel. That's what we said that a process is. That's what we define a process as. And we talked about a process like um the example that was give I don't know if it was the example that was given exactly, but this is the example I have in mind about a process, right? When you write a command on your bash like ls to just give you a list of all the whole application or all the whole folders under a certain file, right? What happens in that simple command, which bash on itself is also a process. What happens is that the bash makes a system call to the kernel, right, telling the kernel to create a new process. Pay close attention, right? I'm going somewhere with this definition. Bash tells the kernel to create a new process, right, and to run this set of instruction inside of this process. And so what the kernel does is just that it creates a new process in inside of its internal table one, this is the process, this is the flow. When he creates it, right, it assigns that process an ID, right? It assigns that new created process an ID, right? And also assigns it a designated amount of memory, right? Then it now loads that that instruction inside of the memory, right? And now sets a context CPU for that memory, right? And before it will now be listed as a runnable, right, that is being managed by the kernel. So that's how the whole process happens in a nutshell, right? That's how the whole process will happen in a nutshell. And we are saying now that the container is and we are saying now that the container is a lightweight isolated process that runs on a shared operating system, right? Um, and also it has all the package needed for it to run in a container, right? And so I will mention that the features of container is that it does not have its own it does not require a separate OS the same way a virtual machine requires a guest OS, right? And then we talk about that another feature is that is isolated and self-contained environment, right? And we talked about the ability for you to create and tear down a container very very fast. Right. Then we talk about repeatability, portability, and ability for you to scale this container. Right. These are the things you mentioned. Um, then we talk about how a container is being built. Right. How do we start a container? Right. We said that for you to be able to build a container, build, ship, and run a container, you will need a container runtime, right? A container runtime is what gives you the ability for you to be able to build, ship and run a container, right? And in our case, let me still go back to this, right? I'm still reiterating, guys. Now, the example we gave, the difference between a virtual machine and a container is that one, a virtual machine has a hypervisor, right, that connects the hardware, which is the server, with the VM, right? While a container has a runtime, a container runtime, which connects the containers um, with the hardware, which is the server here, right? Another difference is just that these containers actually share the same OS with the host, right? But these guys here, they have their own separate full OS, right? So let me go back to this. Okay, okay. So um, now, what I'm trying to say in essence is that for you to build a container, you need a runtime engine, right? Which in our case is Docker, right? So there are different runtime engines actually. Container runtime engines are actually out there, right? But Docker is the most popular, and that's what we'll be talking about throughout this course, right? And you also mentioned that for you to start a container, right, now we already know that for you to be able to build and ship and run a container, you need the engine, the runtime, right? You need the runtime in your host, right? You need the runtime in your host. You need the engine to be available in your host for you to be able to um, run a container, right? For you to be able to do all the access all the features available in Docker, right? And yeah, and then we also mentioned that for you to start a container itself, right? For you to start a container, you need a Docker file, right? So what are Docker files? Docker files are what gives you it's more like a pointer or gives you the um, enough information for you to start a or to build an image. Right? It gives you enough information for you to build an image. It gives the runtime engine enough information for you to build an image. Right? That's what a Docker file does. Right? Whether it be building this image from a registrar, pulling it from a registrar, or building an already existing image, right? Excuse me, excuse me. Okay, so then we talked about images. We talk about the fact that images, right? Pay close attention. This is where it starts becoming a little bit somehow tricky, right? We talked about the fact that when you talk about um, images, right? We have some components that makes up the Docker. We have the Docker client, we have the Docker image, we have the Docker daemon or the Docker D, right? We have the Docker registrar, right? These are the components that we talked about yesterday. And so let's start from the Docker client, right? We said that the Docker client is what gives developers or users that interactive access to the Docker, right? So the user can be able to, run commands, to um, I'll start up a command, right, that is being sent directly to the Docker daemon, right, or Docker D, right, from the client, right. And then we talked about images, right. There was a definition. Let me see if I can put out that definition about images, right. And yeah, our definition about Docker was just that a Docker is a software platform that simplifies the process of building, making and distributing application, right? So let me see if I can pull out the definition of an image here. Just give me a minute. I want to see if I can pull out the definition of an image here. Okay, so yeah, the definition of an image is the definition from our instructor say that an image is a read-only binary template used to build a container. Right, that's what an image, a Docker image is. Right, it's just a read-only binary template that is being used to build a container. That's what an image is. Right. So now, what does that really mean? It means that so now it's telling us that the image has some content, right? So the image contains enough information that will give that gives it access or pointers to build containers that our application can run on, right? And so you that means you can build as many images as you want from a single image, right? You can build as many as possible. Now, you now talked about the Docker D or the Docker daemon as the heart of Docker. And so we say that the Docker daemon is the it listens to um, requests coming from the client, right? The Docker client, right? And it takes those information and execute it as requested by the client. And so also the Docker daemon has the ability to manage Docker, right? And in fact, to summarize it, the Docker daemon, its work is to take full charge of the host, right? Takes full charge of the host, ranging from the registrar to the client side, to building an image. Because when you talk about building that image, really, really, right, is the work of the Docker daemon, right, to build the image, right. The ability for the image to be built is the work of the Docker daemon, right. That's what the Docker daemon does, right. And yeah, I think I've summarized that. Then we now talked about registrars. We talk about that registrars can be public or can be private. At public registrars, you can pull it, and let's say you want a Postgres image, you can pull it from the Docker hub, public hub or Docker hub actually, and build it inside of your host, right, and then run your containers, right. So and the same way you can build an image and then push it publicly for people to have access to, right. I think this is a summary of what we talked about in our last section, right. So yeah, so let me just quickly share this to um a few of us. So, and I want to encourage us to, come to my um, GitHub and just interact with it, right? I want you to interact with my GitHub repository. Right? Give me a follow, give me a like, just interact with my repository. Interact with my repository. So let me just share this. Um, uh, so let's just allow it to load. When it's done loading, I'll just well, it's done loading there. Okay. Okay, so I think that's enough recap for yesterday. So let's just dive into today's class. As I hope you're with your writing materials and you're with your brain to think, and you're with your brain to jot down stuff, and also for us to think together. Let's dive into it proper.
How Docker works inside the host. Remember when we said that the Docker daemon is how it manages, or is the entity that is supposed to manage, create the images, push the images, deal with the registries, understand what's coming from the client, and manage entity that is supposed to manage, create the images, push the images, deal with the registries, understand what's coming from the client, and manage networks and containers and volumes and so on within the host. So does it have any assistance? Let's find out. So understanding how Docker works inside the host. So the CLI will communicate with the Docker daemon or the Docker server, which is abbreviated Docker-D. Then, what would Docker-D do? Docker-D will process the API request coming from the client, and it will utilize Container-D functionality. So there is a component within the daemon that is Container-D to manage the container's lifecycle. Then, does Container-D itself create and kill the containers? So the Container-D will manage the containers, will manage the storage, and will manage the networking relevant to the containers, and it pushes and pulls images. So the Container-D will function within the daemon in order to push-pull messages, manage containers, storage, and networking. Then we have something called run-C, and that is like lower, closer to the container, which will create and run the containers. So now we have the CLI, we have Docker-D, we have Container-D, and we have run-C. All together are going to be within the Docker engine, inside the host, and these are the components that work together behind the scenes. I don't see that, in order to make sure that our requests to build images are fulfilled, our requests to push or pull images are fulfilled, our requests to build containers, to stop them, to terminate them, or to build volumes and storage or networking are all understood, and they are fulfilled as well. And there are volumes and storage requests.
I need to get
in order to
handle
bar the
this actually.
networking functionality.
Let's go back in this.
The images, deal with the registries, understand what's coming from the client, and manage networks and containers and volumes and so on within the host. So does it have any assistance? Let's find out. So understanding how Docker works inside the host. So the CLI will communicate with the Docker daemon or the Docker server, which is abbreviated Docker-D. Then, what would Docker-D do? Docker-D will process the API request coming from the client, and it will utilize Container-D functionality. So there is a component within the daemon that is Container-D to manage the container's lifecycle. Then, to manage the container's lifecycle.
Okay, so what this is saying actually now is that from the client, the Docker client, right? You send a command inside your CL, maybe Docker pull or Docker push or Docker do, right? The client communicates with Docker-D, right? The Docker daemon, which, like we said, the Docker daemon is what is in charge of the host itself and what happens between the registrar and the client and the host, right? Then we are saying now that when this information gets to the Docker-D, what it does is just to process the Docker API request. The request coming in, it process it and then utilize the Container-D functionality. Right, so that means that inside the Docker-D we have what we call the Container-D functionality, right? And what the Container-D functionality is to manage the container's life cycle, right? So it's more like information came in, right? So the Docker-D now assign um, um, the appropriate person that should actually handle this request, right? So let's say you came to a restaurant and um, you came to a bank actually, right? You went to the receptionist, to ask or inquire of something, right? So the receptionist, which in our case now is the Docker-D, right, received that information, right, and now assigned you to the maybe the right person that should handle this request, right, or the right person that should handle this exact issue you're looking for, you're actually facing or you came for to be solved, right? Then so in our case now is the container D, right? So we are saying that container D functionality is to manage the containers life cycle. So let me just pin this down. So we say that container D manages the containers life cycle. So that's the work of container D, and this container D gets its information from the Docker D, right? That was sent by the CLI, right? Let's continue.
Then does containerd itself create and kill the containers? So the containerd will manage the containers, will manage the storage, and will manage the networking relevant to the containers, and it pushes and pulls images. So the containerd will function within the daemon in order to push-pull messages, manage containers, storage, and networking. Then we have something called run-C, and that is like lower, closer to the container, which will create and run the containers. So now we have the CLI.
So now this is what we are saying is that inside of the Docker D, Docker D receives this information, right? Then utilizes the container D, right, which manages the life cycle of the container, right, the container's life cycle. And so we are saying that the container D, what it does is just it manages containers, um, storage and networking, and pushes and pulls images, right? That's what the work of the container D is, right? And so then we said that we also have another component called container C, sorry, run C, right? And so the work of run C is it creates and runs containers. So that's the work. So run containers. I think the abbreviation of C there should be containers, right? Run C, its work is to create um, run C is to create and run containers, right? So that's the function of um, run C, just to create and run containers, right? So let's continue.
CLI, we have dockerd, we have containerd, and we have run-C. All together are going to be within the Docker engine inside the host, and these are the components that work together behind the scenes. I don't see that, in order to make sure that our requests to build images are fulfilled, our requests to push or pull images are fulfilled, our requests to build containers, to stop them, to terminate them, or to build volumes and storage or networking are all understood, and they are fulfilled as well. So let's go ahead and set up the environment that we are going to use, and we are going to do it in AWS. I know.
Okay, so before we do the lab environment setup, let me just share this here. Okay. So let's
A
continue.
lot of you are going to push back and say, why not on my laptop? I can do this virtual machine, I can do VirtualBox, I can do this, I can do that. I have my reasons, so let's discuss that first, and then at the end it's up to you. All I need is a virtual machine that will be the Docker host, and we're going to do all of our labs on that host. Now, why AWS? Why do I prefer to do it in the cloud? If you want to do it in Azure, if you want to do it in GCP, that's fine as well. My point is, let's do it in the cloud. Let's do it in the environment where you are going to be interviewed and asked question about. And also that when you defend the fact that maybe you don't have actual experience in Docker or in cloud or in DevOps, then you can at least say that I have created these projects in the cloud. So you know how to deal with the cloud. If they ask you about AWS or Azure or Google Cloud, then you know and you have dealt with it. It's not a black box for you. So let's go through why I think working in the cloud is way better than an isolated environment or a sandbox. First of all, you are practicing in real world environments that you are going to see and touch when you work in your actual job after you get it. It's much faster and much cleaner to set up and delete. So let's say you bring up a virtual machine, that will be your Docker host. Whatever happens and that virtual machine is trashed, then you can, in 2 minutes, launch another one. You can build confidence, personal confidence, technical confidence in working remotely and collaboratively as well. In today's IT, you could be working with the team in your corporate, but they are in Japan, for example, and you are doing something for them in the cloud in Japan, and you are in the US or you are in Europe. Then the confidence of working remotely and connecting to your infrastructure remotely and building that remotely is going to be gained, as opposed to, this is my Windows laptop, I'm going to do Stack Overflow and find out how to do a VM, but then the mouse doesn't work, I cannot copy, I cannot do this, I cannot do that, and we have lived through hell through other courses with other instructors in our academy about VirtualBox and the compatibility for the different and the resources and the M1 on MacBooks and all that stuff. And then you are going to master the glue between tools. When you do anything, the cloud is going to be there. In today's IT, in I would say 70-80% of the cases, the cloud is going to be there. Some are on premises still. So when that happens, then you will be already using the cloud, using the pipelines, using other tools in the cloud, and this is not new to you. Linux operating system. You are going to be practicing on Linux operating system all the way throughout the course. And again, you can defend your project and your GitHub portfolio for the projects you have done. When you are asked, but you don't have practical experience, then you can reply back and say, yes, but I have done that in the cloud, and I have done that with real environment, and these were not sandboxes or isolated or following a dumb script. I have worked myself from scratch on my projects, and I have done everything from the ground up. And most importantly, because this is why a lot of people, they push back on any environments in the cloud, is cost. And it is free. Whatever we are going to do throughout this course, if you have a brand new AWS account, you will get the resources that we are going to use in this course for 12 months for free. And I'm going to tell you exactly what are the free tier services you are going to enjoy for 12 months without having to pay a penny to AWS, as long as you don't cross the monthly limits that I will explain in a different video. All right? So hopefully that has convinced you to start doing this. All you need is a credit card, and in the next video, I'm going to tell you how.
Okay, so what this explanation is saying actually generally is that he's trying to convince us why the importance of having a cloud VM learning experience is much better than maybe installing, a VM machine locally on your PC doesn't really work. It's not a real world environment experience, right? And most of the jobs out there, their works are heavily, at least 70 to 80% of the works out there are heavily on the cloud these days, right? And also is a place for you to work and have reward experience, have a reward interaction, right? Where you can, because at the end of the day, these are the kind of environment you will face in jobs, right? When you land out your dream jobs, these are the kind of environment. It might not be your local PC, right? It might be a cloud, it might be Azure, it might be AWS or GCP, right? At the end of the day, but there is a cloud system that's maybe that company you're dreaming to work with is using at the end of the day. All right, so that's why you have to, as you're learning, start practicing or start building confidence around these cloud systems, right? So that's what he's trying to say. Over using your own personal PC to run it locally or personally, right? It won't give you much experience or much of the real world application use case.
To create the AWS account. What about if you cannot or you do not want to create an AWS account? You don't have a credit card. You don't want to use your credit card. You don't trust me. You think that they're going to charge you. You want to do it on your laptop because you just bought it and it's new and you're happy with it and you would like to get a return on investment on what you have just paid off. Whatever the reason is, there are alternatives, although you will be missing on all of these points except for the Linux OS. But other than that, it's not going to be a real world environment. It's not going to be fast to implement. You may run into issues. And it doesn't have to do with real world environment. So it's up to you at the end. So what are the alternatives? The alternatives are Docker Desktop Personal, and this works for Windows, Mac, and Linux. And if we click on this link, it's going to take us there. So you have the #1 containerization software developers and terms. And if you want to choose plan, of course, we are not going to pay for that because there is one that is free. The Docker Personal is free, as you can see, and you can get started and then you can fill in your information, whether it is personal or work related, fill in your profile or maybe log in with GitHub or Google, and then you will follow that to download it and install it on your machine. Let me know if you need any help with that. I can help you with that as well. Why I did not include a video for that? Because I am opposing that direction, but it's your freedom. Do whatever you want. Let me know if you need help and I can post a video about how to install it. So this was the first alternative. The second one is on your laptop, you can also do a VM, a virtual machine. So you have a Windows laptop or Mac or whatever, you can carve some of the hard drive and then you can download Oracle VirtualBox and you can start creating containers. And this is from Oracle and this is where you get it from. So Oracle VirtualBox, and then you can download based on which platform you are going to use it for. You can even do it on Ubuntu and other Linux distros as well. So choose the one, download, follow the steps, and then you will install it. This one is a little bit tricky for the mouse and copying and all that, but definitely you can at the end get it done. Again, I'm not opposing, but I'm recommending don't waste your time on that. You need to learn Docker, not how to set up virtual boxes, which you are not going to do in real life. And it is free on the cloud, on Azure, on AWS, on Google Cloud. Choose the cloud that you want. It's up to you. So what are the options we have? We have the virtual machine from VMware Workstation, and that works on Windows and Linux. And again, if you click on this, you will go to the website where you can start downloading Fusion or Workstation, depending on the platform that you're going to use. So this one is Fusion Pro for Mac, and you have VMware Workstation Pro for PC. So choose depending on your device, and you can follow the steps and install it. Again, to your liking. But what I guarantee you in all of these cases is it's going to waste time. It's going to take time. Maybe if you are in IT and you are proficient about this, maybe half an hour, 20 minutes, 1 hour. And if you are not, maybe it will take you days and it will stop you from proceeding with learning. So again, I go back to the benefits of using it in the cloud for free. All right, now since we are going to do most of our hands-on lab and practice in AWS in the cloud, we are going to work extensively in the cloud in this course. And that will be a great opportunity for you to learn the cloud as well while you are learning the IT fundamentals. So what we'll do is we are going to create an AWS account, free, don't worry, you will not have to pay anything. And that will make it easier if you have an old laptop, if your laptop is busy or not performing, it's full, the disk is full, you don't have to upgrade to another laptop, just continue to use it in the cloud. That's it. So what do we need to do? We need to go to aws.amazon.com. aws.amazon.com, and you will get.
So class have started. This is where the main work is. This is where the main work is. Uh, uh,
get a page like this one where you click on create account. So we need to open an account. We have to have an account in order to use AWS services. So I'm going to click on create. And this is a free account. From here, get started for free. And this will tell you about the options you have. You have a free plan, you have a paid plan. What's the difference between the two? The free plan is an account. It doesn't give you access to all AWS services. So there will be some services that you will not be able to use. And scaling of services is going to be capped. So when you are working and you are trying to scale and do like advanced stuff, it will not scale accordingly because there are some thresholds based on the credits. So these are the disadvantages. And the account is going to be closed after 6 months from creation. You will receive $100 credits as soon as you open the account. So you can use AWS services worth $100. If you use them in 1 month, that's it. The account is unusable. You cannot add credits unless you change it, upgrade it into a paid plan. And there are some activities that if you do, exploring some AWS services, and if you do them within the 6 months, you will get another $100 credit. So you'll have $200 credit, and that's a lot of money for someone who's learning AWS. I mean, that could easily help you do a lot of AWS stuff that would take a year to work on. And you will have free usage of select services, and there's no charges whatsoever. So if you are worried about incurring any charges, that will be the account. But of course, you have limitations. You can always upgrade within the 6 months to the paid plan. And in the paid plan, the same thing. You get 100 credits and another 100 if you do the AWS services exploration, includes free usage. You can scale and all that, but you are going to be charged if you go beyond the thresholds. Workloads can scale beyond credit thresholds because it's paid. You will pay for it. And you have access to all AWS services. If you need to know more about the differences, there is an FAQ. So these are services that are available in both. And you can keep exploring which services, and you can always click on show more, and it will tell you if this is available in both or not. And you will get this is the FAQs. And in the FAQs, they will tell you about, so here the free plan accounts, paid plan accounts, earning additional credits, what you need to do exactly, and what are the activities that you need to do in order to explore that. How do I earn additional free credits? And you go through this console home walkthrough and dashboard, and you can find out what needs to be done. So you have everything you need, and you can find it by yourself without having to ask me for any questions regarding these accounts. All right, let's go back to creating the account. You need to write an email that is going to be the communication between AWS and you for bills and for updates and so on, and a nickname of your choice for the account. So once you have entered the email and the nickname, click on verify email. So what they will do is they will send you a verification email to ensure that this email is an active email and you have access to it. And once you verify, you will be taken to the next step. So once you enter the email and the name, you will get into this CAPTCHA where you have to do the security verification. So go ahead and do it, and then click on submit. Once you do the CAPTCHA, enter a code that was sent to the email that you have specified. So you need to get that code from the email and enter it here, and then click.
Okay, so I'll be doing this process, right, at the end of this life, right? So I won't be doing the whole setup. So I want to encourage you to follow along and do the setup. So why I don't want to do the setup is for security reasons actually. So I want to be doing the setup. I want to encourage you to do the setups as you are seeing on the screen, right? So I'll do the setup. So from our next live section, we will now start the full implementation, right?
Verify.
But as much
And
as
as you can see,
lies in you,
the email
just
has
follow
been
suit.
verified now. Now you need to configure the root user password. Basically, the username will be the email that you entered, and this will be the password, and this is the most powerful user in your account. So you have to be very careful, and it's better to use a password phrase, not an easy to guess password. And the conditions are available here. It has to be at least eight letters long, at least and it includes three of the following: uppercase, lowercase numbers, and non-alphanumeric characters. So go ahead, create your password and confirm it, and click on continue. You have the two options that we talked about, the free and paid. It's up to you. If you don't want to be charged under no circumstances, but you're okay that you will bump across some services that you are not going to be able to use. And of course, for this course, the free plan is more than enough. I would go with the free plan for now. Now you need to select what will be the use of this account. So I'm going to click on personal, put all the details, your personal details. It has to be accurate. The phone number has to be accurate. The country and all that has to be accurate, because they are going to send you a code to your phone and you will need to verify it. So now they have verified the email, they will need to verify the phone number as well. So fill this, and after you do, then tick this box and click on agree and continue. Now you will need to enter credit card information. You might be wondering, why is AWS asking me for a credit card if this is a free plan? Simply, they need to verify your identity in three different ways. Email was one, phone was another, and now credit card information. That means they know you, they can verify, and there is no way you can have wrong information entered here, because they will check, and probably they will hold like $1, €1, or a small amount, only hold. They are not going to charge it, and it will be released in a few days. But this makes them sure that there is a payment method just in case in the account. And if you upgrade to a paid plan, then any extra charges are going to be charged to this credit card. If you are on the free plan, they will not charge you. So don't worry about that, but you have to enter this information. There is no way out of this. So fill this information and click on continue, and I'll see you in the next page. Now is the sign up for AWS. You need to confirm your identity, and now they have given you an option. They can either call you and give you a code, or you can receive a text message. So both of them are used to verify that this phone is yours. So go ahead, fill in the information and click on send SMS, or you can have a voice call if they want to call you and give you the code. Either way.
Okay, so I want to say something as somebody that have used these payment methods before, right? It's the reason behind these payment methods for me, from my own experience, is that they will want to which actually they will reach out actually beforehand that your free plan have expired or we expired on so and so date, which if you didn't see the message on time, right, after your free plan expires, they will want to bill you, they will want to debit from your account, right, which have happened to me before. I mean, it happens to me almost every time, right? Yeah, so I'm just saying it out there so that you have it at the back of your mind that this credit card that you're imputing, there will be chances that if you don't pay attention to the messages that AWS will be sending across to you, at the end of 6 months, you will be charged. Only if there is no money in that credit card as of when they want to charge you, you will now receive a message of that your payment didn't went through, your upgrade didn't went through, maybe update your credit card and stuff like that. That's how it normally usually do happen, right? So I'm just giving you that for free so that you be aware.
Fill in the number, click on send, and then they will text you, or they are going to call you, depending on your choice. Go ahead, do this step, and I'll see you in the next page. Now you are faced with another CAPTCHA, and then they will send you the verification, or the verification code, or the text message. So you have to fill this CAPTCHA, and then you will get the code. All right, so this is the page, and you will get the code. Enter it here and click on continue. Okay, so I got the code. It is 5320. 5320. Continue. Okay, in my case, because my credit card, my phone number, and all that exists already on AWS, they are refusing to give me a free plan, and they will upgrade me to a paid plan. So anyone who created an account before in the good free tier all times, where we could create 5, 10 accounts and use free tier in all of them for 12 months, this is not the case anymore. You need to use a new credit card, a different phone number if you would like to get around and have another free tier. In your case, this shouldn't be a problem, because if you are a newbie to AWS, this page will not appear to you. So in my case, I'm going to say, okay, I agree. I'm not eligible for the free plan anymore. Anyways, I'm going to click on confirm, because I want to show you the rest. So that page will not appear in your case. Now we come to the support plan. Leave it to the basic and click on complete sign up. All right, so I'm going to click on that. And guess what? Congratulations, you have an AWS account right now. Click on go to AWS Management Console. All right, so once you log in, that means you're going to the Management Console. This is the portal. This is the orchestration and automation and management tool in AWS. So I'm entering my account right now. All right, so let me take you through a walkthrough of the AWS Management Console to help you get familiarized about the AWS Management Console, how to use it and all that. Let's go ahead. Okay, so these are few messages. If you'd like to go through them, that's okay. For me, I'm not going to go through them. Let me make this a little bigger. So this is the console home for a brand new account. So this is an account which doesn't have any recently visited services or anything. If you click on this side, you'll find the account ID. You can go to billing and cost management, where you can look at your bills and find out your consumption and so on. You can sign out. And here you can see that you have.
So what he's trying to do is just to give us a tour of how this AWS console, how it works. Remember, he said that when you sign up successfully, where you should be heading to is the console management, which will land you on this page. Then he's now giving us a detailed tour of what these different buttons or different cards and different links are for, what they're about, right?
All the AWS regions. So by default, it has chosen for me this as the default, the one in Stockholm in Sweden, but you can switch to a one closer to you, because that will help you with the internet latency. If you want to play with an AWS service, work with an AWS service, then you can click on here, and you can see that you have here a list of AWS services. Or if you know the service that you are going to work with, for example, in this course, we are going to work a lot with EC2. This is the service that allows you to create virtual machines in AWS, virtual servers in the cloud, basically. If you would like to launch your own presence in AWS, you have to create what we call a VPC, or Virtual Private Cloud. There are some services under VPC that are created for you by default. You don't have to do anything about them, and they are there for you. AWS assumes that this is like a common denominator that most of the people who are learning might need it, and they volunteer and they create it for you. We're going to learn more about this later on. If you go into one of these services, I'm just going to show you how it looks like. You don't have to know anything about it right now. So usually you have the dashboard. So this tells you where exactly are you right now. So I'm in the VPC dashboard, Virtual Private Cloud dashboard, and these are the settings that I can choose, or the stuff that are under the VPC. When you choose one of them, what you see on the right-hand side will be the details of what you have selected. So for example, if I click on this, these are the subnets under subnet. VPCs, this is the existing VPC. Root tables, these are the existing root tables. Now let's go to EC2, which is the virtual machines in the cloud. And as you can see, this is the service. Here is the EC2 dashboard, as it says. Instances means virtual machines, and instance types and launch templates, and there's a lot of configuration stuff that also fall under the EC2 dashboard. For example, if I wanted to create a virtual machine, and you will be amazed at how fast you can do that. So I'll click on instances. I don't have any, as you can see, but I can choose to launch one. So this is the page that at the end, when you fill in all the information, you can just click on launch instance and boom, you have a virtual machine in the cloud. So what do I need to do? I'm going to call it first VM, first virtual machine. And here you have the operating system. So you can do Amazon Linux, you can do Mac OS, Ubuntu Linux, Windows, Red Hat Linux, SUSE Linux, and so on. So there are plenty of operating systems you can run on the virtual machine. Remember that the virtual machine needs a full guest OS. And after that, I'll leave it to the default. So I'm assuming that I'm going to go with an Amazon Linux one. Any virtual machine has a VNIC, virtual memory, virtual disk, virtual CPU, and so on. So if you look here, you'll find that this is T3.micro. That's the size of an instance or a virtual machine. And it comes pre-packaged. So the T3 micro will always have 2 vCPUs, 1 gigabyte of memory, and here it tells you the prices per hour if you use it. So in my case, I'm going to choose, let's see if I can get to a smaller one. No, that's fine. That's the least I can do. So T3.nano. Key pair. If you would like to access the instance remotely, then you have to create a key pair. Otherwise, I can do proceed without. We're going to explain that later on. Network settings, which VPC or where it's going to land. I'm going to leave everything to the default now because I'm just explaining that to you.
You know what is happening? What is happening here, if you're lost, is that we are trying to create an instance. We are trying to create a VM machine. That's what is happening here. I want to create a VM machine that has its own operating system. Let me just, for people that don't know the existence of cloud, right? Cloud is more like what gives you access to data centers, right? It's more like people that are selling out data centers, right? That's what it actually looks like. Just saying, putting that out there in the person.
Security. And once you are done with all of this, all you can do is launch instance. And congratulations, this is your first virtual machine in the cloud. Successfully initiated launch of this instance. And if you click on that ID, You get to here, and you will see that it is running, and we have created a virtual machine. Of course, as you learn the particulars or the specifics about each one of the attributes that we needed to configure, then probably it will take you another 10 seconds, 15 seconds, but you will have a virtual machine in no time. You don't have to virtualize your laptop. You don't have to learn about new tools like VirtualBox or VMware Workstation, and you don't have to do nothing. Your laptop is as is. You don't need to split or partition it to include a VM. You don't have to do nothing. In the cloud, in your case, if you are new to AWS, it's going to be free. You have $100 credits, and you can do some exercises and gain another $100 credits, and it's going to be there for you for 6 months. You don't need anything else to do. All right, and at the end of the 6 months, as you advance, you can upgrade to the paid plan, and then you start controlling your expenses based on your usage, basically. You are investing in the environment that would look like the actual environments you are going to work on as you specialize in your career. All right, hopefully that was clear. What I need to do now is I'm going to terminate the instance because my account is not a free account. And once I click on that, guess what is happening right now? You'll find that it is shutting down and it will be terminated in no time. The second thing you need to do, and it is recommended by AWS, is I'm going to head to a service called IAM, Identity and Access Management, or Manage Access to AWS Resources as they call it here. And we need to click on users, or I can go into IAM, and I would like to create a user that is going to be the one that we'll use from now on in the account. Why? Because it's recommended by AWS not to use the root account that you have used to create the account, because that is the one that has the most privileges in your account. It's not recommended to use that one for the day-to-day stuff. So what I will do is I'm going to create a user. I'm going to call that user, let's say, admin labs, or can be just admin. And I would like to provide access to the AWS Management Console. So we're going to go ahead and do this. And I'm going to create an IAM user as we mentioned, and I'm going to create a custom password for that user. Okay, you can click on show password if you'd like to view it. I don't want to share that with you. Next, do you want to add the user to the permission or attach policies directly? This is not recommended. It will work, but since this is not an AWS course, let's not get into a lot of details. So administrator access, this is the highest privileges you can provide to any user. So I have looked for administrative, and this is the administrative access. Tick the box next to it, and then click on next. This is the permissions that you are going to provide to the user, and create user. So from this point onwards, this is what I'm going to use. Now, if you want the credentials to be maintained, all you need to do is you can download the CSV file. It will have this is the URL that the user needs to use all the time in order to log into the account. And this is the password. The only time you will be able to view this password is right now. So you better download the CSV file, and this is the user. So I'm going to use this in order to get into the account, and you will notice here that the name has changed. So I'm going to copy this, and I'm going to download the CSV file. Please save it in a place where you know that is handy for your case. I saved it just in the downloads. I can relocate it later on. And then now I can return to the users list. I can email that to myself if I would like to. So I can email it to marketing@dolphin8.com, and I'm going to log out and try to log in with the user and see what happens. So I'm going to sign out. And here I'm going to use the URL. As you can see, this is the sign-in URL that we have copied. And I'm going to hit enter now. So if you notice now, it has, from the sign-in URL, it had found out what is the account ID. So all I need to enter now is the user and the password. And now I think I wrote something wrong. I think I misspelled the password, but I checked the CSV file and I found it. In your first sign up, you will be prompted to change the password. So basically, the one that you have created with the user is a one-time, and you have to change it, and that's a protection. Once you change it, you are going to use that one from this time onwards without having to change until it expires. And by default, I don't believe there is an expiry, but if there
Please, if for any reason you have any question, just drop it on the comment section. All right. So you might be asking why I'm not following this along. I'm here to sign in my credentials, my credit cards, and all those stuff. So I will not be doing it live. So after this live section, I'll go ahead and set up my environment, right? And then in our next live section, we will now, start talking about how all these things work. So now, what happened in this AWS environment we just learned today is just that we created an instance, a VM machine, right? We terminated it, and we created an IAM account, which is recommended by AWS. And why is it necessary? So instead of using your initial details that you use to log in, right, which has all the whole privileges, right, you can just assign a new user, right, that have limited privilege, right, for your day-to-day activities, which is much more better for security purposes.
is, it will be like 90 days or something. So you have ample time to use it without any issues. So let's go ahead and change the password. So now you will see the difference here on this side, that it's not the course labs anymore, it's admin at the account ID. All right, so since we understand how to work on the AWS account briefly right now, then let's take it to the next step. Let's go ahead and launch an AWS EC2 instance, an Ubuntu Linux instance.
Okay, so this is where we'll be stopping for today, right? This is where we'll be stopping for today. Um, um, in our next live session, right, we will continue with the rest of the implementation. Right, we start interacting with AWS Ubuntu Linux, like we see here in the next section. So we'll be stopping here today. Now, I want you to, one of the beauty of this class now is that it's no longer theories. Sorry, we have passed the theory phase. So if I were you, actually, I would try as much as possible to interact with AWS environment, right? Interact with it, read the Q&A, read the Q&A very well, right? For any confusion at all, right? Google some things, ask AI for some clarification. What does this mean? What does EC2 mean? What does IAM mean? Get familiar with the environment. It's not that difficult, actually. I'm saying this for people that are new to AWS or cloud activity. Yeah, it's not that difficult. It's something that you get familiar with as you go, right? And it's not something you should force yourself, right, to get familiar with all the whole concept of AWS or the cloud at a go. You'll be overwhelmed, right? And I know that the environment might be a little bit overwhelming, right? Try as much as possible to overlook a whole lot of things and focus on what is needed for this course. Why I'm saying this is that it will save you a lot of time, it will save you a lot of overhead, right? And the more you use AWS, the more you use the cloud, the more you get familiar with a whole lot of concepts here and there. The more you get familiar with a whole lot of security measures, the more you get familiarizing yourself with a whole lot of dashboards, right? And so that's my take for today. I see you guys in my next live section. Peace out. Right, so now, but let me just reiterate what we talked about. So today we talked about majorly on how Docker works in the host, right? How Docker daemon actually works, right? How the API sends, the CLI sends communicates with the Docker daemon. Now, Docker daemon utilizes the container D, which is part of the Docker daemon. And so the container D, the function of the container D is for storage, management of networking and building the container generally, right? So and the RUC, they run C, right? They run C. Its function is for it to create and run containers, right? And so I'm saying that if the function of the run RC is to run and to create and run containers, the work of container D is to manage the containers life cycle, right? So that's the work of the container D, to manage the complete life cycle of a specific container, right? So run C creates and run these containers. Container D manages them, manages the container that is being created and run by container C, and run by run C, right? Then container D manages the container's lifecycle and also push and pull these images, right? It pushes and pulls them from the registrar into your host machine, and from your host machine to the registrar, as the case may be. So this is the major thing we talked about. Then we now talked about how to create and set up AWS and the importance of using AWS over installing a VM machine locally in your device, which we have seen that AWS, in fact, cloud system actually is much more faster and much more efficient and much more job hands-on than installing any maybe Oracle or Linux or any other VM machine locally on your on your PC, right? And we went ahead to do our setups, which is very very simple to walk through, right? And then we created an instance. An instance is a VM machine. Created a VM machine and we terminated it. We used the smallest RAM and we saw how much will be charged for that specific VM, the virtual components, which is the VNex, right? Um, then we talk about how to create an IM and why IM is important over creating what's it called? Why IAM is important over using your initial um, account ID to run your day-to-day AWS activities, and majorly it's just for security reasons. Right. See you guys in my next section. See you guys in my next session. Bye.